All right, everybody. This is the graphing motion review, and this is for your graphing motion test, which is on Thursday and Friday in your physics class. And this was a handout which was given that you could have picked up. It's a hard copy. But if you don't have the hard copy in front of you, you have plenty of pictures and data here in front of you that you won't need the hard copy even. All right. So first of all, we're going to look at some distance versus time graphs. And we're going to say what kind of motion would create this graph. So let's look. What do I have to do to create this first graph right here, which I have a distance versus time graph? Okay. If you notice, a distance versus time graph, first of all, always tells you speed. That's what this tells you, is your speed or velocity. Now, the reason it tells you velocity is because it does tell you which direction you're going also. So this right now, I'm keeping my distance the same. The distance is not changing. It's constant. So if you look right here, it's the same. So what am I doing right now, motion-wise? I am standing still because this particular graph right here, this line has no slope. Since it has no slope, that means that there is no speed. So I'm standing still. How would I walk to create this next graph over here? So I'm going to look over here at this graph on the right. Well, this line has a positive slope. Positive slope. So since it has a positive slope, it must have a positive speed. So what does that mean, or positive velocity? It means that I am going forward, okay, and that I am going with a constant speed. Now, the reason I know that it's a constant speed or constant velocity forward is because of the fact that it is a straight line. Because it's a straight line, I know it is constant. If it had been a curve, I would have been changing speeds. But since it's a straight line, I am going a constant speed forward. All right, let's look at these graphs. This one, how do I create this graph? What do I have to be doing? Well, again, it's a straight line. But if I look at the slope of this line, it is a negative slope. So that means it is a negative velocity. Negative velocity just means that I've roughly turned around and decided to go the other direction, or I'm going back to my starting point. So when I used the example in class that I'd ridden to McDonald's and then I'd hung out and ate my quarter pounder with cheese and then I came back to the high school, this would be my traveling back. So this is my negative velocity. So also the other thing to realize is that because it's a straight line, then that means it is a constant speed. Okay? There's little things to remember. Okay? How would I create this graph over here? Notice that it has two different sloping lines. Well, both of them are positively sloping, but this slope right here, this beginning slope, is a lot steeper than this slope. Because this blue one is steeper, this is a faster speed than your red one is. This is a slower speed. But they're both positive, which means I have a positive velocity. Positive velocity means we're going forward or away from our origin or our starting point. And so I have a positive velocity. And the first part, I'm going faster than the second part. But again, straight lines. Straight lines mean, since they're straight lines, we have constant speed. So I'm going one speed, which is fast, and then I go at a slower constant speed. All right, let's look at these. Now, when I did these like this. So these will go together accordingly. So make sure that you realize that I did them this way. All right. On the first one over here, which is number 5 on your handout if you have it, but if not, we can just look at the graph. We have 2 lines. We have line A and we have line B. And so I'm going to make line B green, and we're going to make line A pink. Okay? So which one has a higher speed? Well, you're going to, remember these are speed graphs, so you're going to look at the slope, because the slope equals the speed. So which has the higher speed? You want the one with a higher slope. So the answer to that question would be B. Which one started ahead? Now, this one actually is an interesting question because the one that started ahead is A. The reason it started ahead is because look at where its distance started. B started way down here, where A started up here on the distance. So A started ahead in this race, but it didn't finish first because of the fact that B was going at a faster speed. What happens at the intersection? So I want to know what happens right here. Well, believe it or not, if I calculated distance divided by time, at that exact moment, they would both have the same speed. So they have the same speed and they're going the same direction. And direction. So another way for me to have said that would have been the same velocity. Now looking at this bottom area that I went ahead and put in red, I did a big circle in red, we're going to go ahead and make A yellow here and make B blue. B for blue. Which object has a higher speed? Well, again, you're looking at this as to which one has more slope. Because with speed, we weren't talking about direction. We're just talking about the slope of the line. So which one has a steeper slope? Again, it is B. Because it has a higher speed. It's just going in the opposite direction. Which one has a negative velocity? That would also be B, because it has a negative slope. All right, the negative slope tells me the direction it's going on a distance versus time graph, which means it is going in reverse or heading back towards its origin. So hopefully this helps a little bit in the fact that you can tell if it's going away or coming back or in reverse if you have a distance versus time graph and you're looking at it like this. Okay? So let's go to this one. Which one has a higher speed? Again, look at the slopes of the line. Which one has a steeper slope? Well, for this particular example, the steeper slope is A. Which one started ahead? Well, B, which I'll say is here, A is here. So which one started at a distance that was further away from your starting point? The one that started further away from your starting point, or started ahead, is A. Now, some people will say, well, if they're heading back to the starting point, didn't B start ahead? I would go ahead and I could go with that if you went with the concept that they're both going back to a starting point. Okay, which was closest already to the starting point? Well, that would have been B if you looked at it that way. So really, I can accept either answer here. It's all in how you explain it. Because if you said, well, A has a higher distance, that does start ahead. Okay. Again, what happens at their intersection? Well, intersection would be the same speed because we could take distance divided by time and find out that our speeds are the same. All right. Okay. Let's talk about drawing some of these distance versus time graphs, okay? So I want you to sketch a distance versus time graph that's going to correspond to the description of motion that I have here. So an object moves with a constant velocity away from the origin. Well, we're going to draw a distance and time graph. This is in seconds and this is in meters. That's what I'm going to go ahead and say. And it's constant. The thing to realize here is we're going to be constant. Since we're going to make it a constant, steady velocity, and it's away from the origin, then I'm going to make this a positive line. Okay, it's a line because it's constant. away from the origin makes it positive value. All right. This next one, we have an object that is standing still. So I have my distance in meters and my time in seconds. All right. If the object is standing still, then it's just going to be a flat line because it needs standing still means no slope because these are distance versus time graphs. So these are speed graphs. All right. This one down here, the object moves with a steady or constant. Let me get my axes labeled correctly here for a minute. Oops. Time is in seconds. Okay. So it's going to be a constant. Okay, so that means it's going to be a line toward the origin, which is a negative, for 5 seconds. Okay, so I'm going to have to put some time on this one. I'm going to put 5 seconds here, and then we'll put 10 seconds. 5 seconds, 10 seconds. All right, so it's going to move with a steady or constant velocity towards the origin, which makes it a negative. And then it's going to stand still for 5 seconds, which means it has to be a horizontal line. Okay, so that's how it would look. Is we would go down, we'd have a negative sloping line, and then it stand still means no slope. So a flat line for 5 seconds. All right. Now my next one, let me get my axes here. So we have time and distance, and my time looks funny, sorry. My T looks like a crazy person wrote it. Okay. So an object moves with a steady velocity. Let me shoot that in. Away from the origin. So again, we're going to talk about away meaning positive. And it's steady velocity. So we're going to just say that that's going to be constant for 5 seconds. Then we're going to reverse direction and move at the same speed for toward the origin, which is negative, for 5 seconds. Okay, so these have to be the same sloping lines because it says this right here where it says same speed. So we're going to first go away from the origin for 5 seconds. And then we're going to go towards the origin for 5 seconds. Again, I tried to make those the best slope that I could, but we just changed directions. Now let's talk about this last one. The object moves away from the origin, starting slowly and then speeding up. So we're going to go ahead and write our axis. Distance is meter and time is seconds. Okay. If it's moving away from the origin, then it's going to be positive, and it's starting out slowly. Okay. And then it's speeding up. So that would be a curve because this is going to be that it is accelerating. Since it's accelerating or changing speeds, we need to be able to have changing slope. So we have a curved line instead. Okay? Hopefully this helps with your distance versus time graphs. All right, we're going to move on to velocity versus time graphs. And let me move my little thing over here out of the way again. Okay? So if we're talking about velocity versus time graphs, remember these are telling us acceleration. Okay, so for example, on this first one, what's happening? Well, we're staying at 1 meter per second every second, so we're on cruise control. Or we have a constant speed. This is zero acceleration. Oops. Okay. Now on this next graph, we're starting at 0 meters per second, but we're ending at 2 meters per second. Now we're moving into quadrant 1, so this means we're going a positive velocity. Oops, velocity. because, and this other one, I'm sorry, I didn't say that back over here. This one is a positive velocity as well on this last example because it's in quadrant 1. All right, since this is in quadrant, the one we're talking about in blue now is in quadrant 1, it's a positive velocity, which means we're going forward or away from our origin. But because it is a slanted line with a positive slope, this means I am accelerating. Okay, so it's a positive acceleration would be a way to think about it. So I have positive velocity. I have positive, which means my speed and my direction are positive, and I have a positive acceleration. Okay. Next one, how do I create this graph? Okay, still in quadrant 1. So since I'm still in quadrant 1, I'm still going in a positive direction. I'm still going forward or away from my origin. But because this is a negative slope, that means I am decelerating. Deceleration. Okay, so I am decelerating, but I'm still in the positive direction because I'm in quadrant 1. So I'm still going forward, but now I'm slowing down. Okay, this next one, my line is way down here in the -1. Because it's in the -1, I'm actually keeping there's no slope, so it's 0 acceleration. So I'm not speeding up or slowing down, but because I'm in quadrant 4, I am going in the reverse direction, or I'm going backwards. Okay, is a way to think about it. So I'm going in a backwards direction. Now this one right here, again, I'm in quadrant 4, so I'm still going in the opposite or the negative direction. So I'm in reverse, or I'm in the opposite direction, or negative direction, however you want to look at it. And, okay, the way to think about this is a positively sloping line. So most people will say I'm accelerating. But because I'm in quadrant 4, okay, in quadrant 4, I'm in a negative quadrant with a positive acceleration. So this actually means I'm slowing down. Okay, because it's in quadrant 4, which is a negative, and it's a positive acceleration, a negative times a positive is a negative value. So this is like decelerating. Deceleration. Okay. So just realize that. And plus, this is that mirror image that I was talking about, that if I were going, if this line was in my quadrant 1, it would look like, let's go in blue. It would look like that, yes? And if we drew that in quadrant 1, that means we're slowing down going forwards. So if you take the reflection across the x-axis, that means we're slowing down, but in the negative direction. Because that's all you have to do to figure out these is just take the reflection across the x-axis. And so whatever you would do going forward, you'll do the reflection of it going backwards. All right? Hopefully that helps on those types of graphs. Now figure out the total distance traveled by the object. Okay, remember to find distance on a velocity versus time graph. Why did I write a D? Velocity versus time graph. To find distance, you have to do the area under the line. So we're going to solve for this area right here. Since it's a square, I'm going to just do base times height. That equals my distance. My base here is going to be from 2 to 5, which is 3 seconds. My height here is 2 meters per second, which allows me to cancel out my seconds when I multiply these, and I get 6 meters. That's the total distance that I traveled during this picture because I was sitting still, and then I accelerated immediately up to 2 meters per second, and then I decelerated immediately to 0, and then I stayed still for the next 5 seconds. Okay, so moving on. Okay, let's sketch some graphs. We're going to do velocity versus time graphs this time. So velocity is meters per second. Time is in seconds. And I'm going to draw 0 because these are the ones I can draw in quadrant 1 or quadrant 2. If the object is still, then it has no velocity or no speed. So it's just going to be on the 0 line. Okay. For this one over here, I have my velocity in meters per second. I have my time in seconds. Now, what is every one of my graphs missing, really? I'll be honest, they're all missing titles. So be real careful about that when you take your test, please. Make sure you put titles on all your graphs. This one, we have the object is moving forward at a constant velocity. Well, constant velocity means that it's on cruise control. Cruise control. And it's not accelerating, so this graph isn't going to have any slope. So this is going to be 0 acceleration, which means 0 slope. So, and it says it's moving forward. Since it's moving forwards in quadrant 1, and it's a straight line in quadrant 1. Okay. Then our next one, we have V is meters per second, and time is in seconds, and this is 0. Okay, the object is moving backwards. Let's do this in red again. Backwards at a constant velocity. Well, backwards throws it into quadrant 4. Okay, constant velocity means that it is no slope because it's 0 acceleration. So we're just going to draw a line in the 4th quadrant. All right. Now, an object moves forward. Let me get my nice little velocity versus time graph. Meters per second. Time is in seconds. This is 0. It's moving forward rapidly at a constant velocity. Well, constant velocity still means that it is 0 acceleration. But the fact that it's saying rapidly just means that it needs to be a higher line. Forward means that it's in quadrant 1. So it's just going to be way up here instead of closer to 0 line. Okay. Then we're going to do this. 0, V is meters per second for velocity. Time is in seconds. Now this object is going to move forward, quadrant 1, slowly at a constant velocity, so 0 acceleration. So this one's going to be lower than the previous one because it's slowly instead of rapidly. All right. And the object is going to move forward. Velocity is meters per second. Time is seconds. And at a constant, okay, let me look. It's moving forward, so this is quadrant 1. Constant velocity, so this is going to be no slope. For 3 seconds, and then it is still. Well, when it's still, it has to be on the 0 line. All right, so I'm going to draw my, 1, 2, 3, 4, 5 seconds here. Okay, for the first 3 seconds, it's got a constant velocity, 1, 2, 3, and then it's going to the 0 line. Okay, so it's flat at for 3 seconds, and then it is dropping and going to the 0 line for the rest of it. All right. I think we have 2 more. Oops, I didn't do any more. Oh, okay, well, I'm just going to draw them on this page because I can draw them in yellow. So we're going to keep going. All right, because I have 2 more and I didn't for some reason. Oh, no, that was it. Okay, not bad. Hopefully that helps. I will remind you, distance versus time graphs. Slope of the line is speed. Anything positive slope is going to be forward motion. Okay, I do not spell. Forward motion. Anything with a negative slope is reverse motion. Anything with no slope is no motion. A positive curve is going to be speeding up. A negative curve is going to be slowing down. All right. Then let's do white for velocity versus time graphs. Velocity versus time graphs, remember the slope of these lines is going to be acceleration. Remember, if it's quadrant 1, it's moving forward or away from the origin. If it's quadrant 4, it's moving in reverse or back towards the origin. All right. It can have a positive slope um, if it is, let's say, accelerating. Oops. I do know how to spell, I promise. Okay. Let's erase that. And remember, this is in quadrant 1. I'm just going to tell you about quadrant 1. If it's a negative slope, it is decelerating. So this is all for quadrant 1, remember. And then if it's a flat line, it is a constant speed. All right. So hopefully this helps a little bit in making sure that you kind of understand forward, backwards, that kind of thing. Remember, your graphs need to include information on your labels, on your axes. They need to be labeled and have units. You need to have titles, and you need to plot data points correctly. Hopefully this clears a few things up. Good luck on your exam. Check you later.